Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 20th. Looking at significant wave heights for the North Pacific Ocean, we see an area of disturbed weather producing 25-foot seas. Really, this is part of a gale that's been circulating in the western Gulf and is slowly moving its way towards the U.S. west coast. A little pulse of swell from this system already hit on Saturday, and more is on the way for the early part of the week. As usual, we'll start this week's presentation off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales and/or storms. When those storms do form, help direct their path. What we're looking for is troughs, that is a dip in the jet stream, like right here. We see that little pocket here of 140 knot winds, and that would help support counterclockwise flow aloft in the atmosphere, and also down at the surface, that is low pressure, and low pressure, of course, generates wind, wind generates seas, seas as they radiate away from the fetch, create swell, and swell, of course, makes surf. So we have a little trough here, also a little trough over the actually west of the Kuril Islands. And notice here, the jet is almost consolidated over Japan, weak but almost consolidated, but well split over the majority of the Pacific. This is classic sign of the inactive phase of the MJO, and typically means there's not a whole lot of wind energy to support storm formation. That is, when you don't get enough wind energy, the jet splits and sort of meanders all around, and that's exactly what it's doing now. Put this into motion. You can see this trough here into Monday, edges its way towards the U.S. west coast, and then finally pushes into Northern California Monday night into Tuesday. But also notice winds start picking up here over the West Pacific up to 150 knots. This is on Monday night, and the split point slowly starts moving towards the date line. Now notice winds aren't particularly strong back over Japan yet, so it's hard to say at this point whether that's just a tease or not, but a consolidated jet normally is much more productive in terms of producing gales and/or surf. So we get into Wednesday, Thursday. Notice another little trough trying to get organized here, and but not particularly strong. Winds kind of weak under it. Big split here. This would support high pressure, actually that kind of a circulation, clockwise circulation. We roll this out a little bit further, and then as we get into the weekend, notice winds starting to build here and looking a little bit more robust, and by the time you get into Saturday, 190 knot winds are forecast. This looks very much like what we want to see having build across, or at least get to a point somewhere north of Hawaii. That would set up potential for storm development in this area and make surf for the whole U.S. West Coast and Hawaii. As we just roll this out, nothing's really going on here. Yeah, a little trough here on Sunday in the eastern Gulf of Alaska, but this is far more interesting here off Japan. And notice there, pretty good trough setting up come Sunday with 180 knot winds supporting it. We'll roll this out one more tick, 190 knot winds. Now, of course, looking a week out, can't believe any of it, but it suggests that the upper level pattern is to improve, though we still have this high pressure sort of bad split pattern over the U.S. West Coast. So long term, though, things are looking better. Let's go take a look down at the surface. So here we are, surface level pressure, surface level winds. As expected, the trough here in the Gulf of Alaska is generating 30 knot, almost 35 knot west winds, targeting the U.S. West Coast, but very close nearby, likely resulting in a rather raw and ugly swell pattern. Another little sort of cutoff gale here west of Hawaii on the date line. And then, as expected, there was another trough here west of the Kuril Islands, and sure enough, that's supporting some sort of low pressure there as well. We'll roll this out a little bit further, see how things move out. That gale moves into the U.S. West Coast on Monday. Another gale forms here, the one that was cut off, moving on a northeast track, 45 knot winds, moving kind of fast. So it looks like it's good to produce some sort of swell, or seas at least, aimed mainly up here towards the Pacific Northwest because of that northeastward movement of the gale itself. And high pressure reigns supreme off the U.S. West Coast into Wednesday night. And then things sort of fall apart. But remember, the jet about this time later in the week starts building. We see a series of low pressure systems trying to organize come Friday and into Saturday. This one gale here off of Kamchatka and the northern Kuril Islands, certainly capable with 35, almost 40 knot winds to produce something aimed at Hawaii. Nothing dramatic at this point in time, but notice as you get into Sunday, this thing starts really growing in coverage, filling a good bit of the North Pacific as we move even into Sunday night. The core of it moves up north of the Aleutian Islands into the South Bering Sea, but still, this suggests that we're moving into at least somewhat of a more favorable pattern. Right now, things are pretty lackluster indeed, so anything along this vein would be good. Let's go take a look down at the surface. We're going to go back in time here real quick to Wednesday of last week. This area right here, we also see, yes, there was another gale off Kamchatka. Swell from that is about, if it's not hitting Hawaii, it's poised to hit the Hawaiian Islands, but given the long travel distance away, swell was not very much. So here was the system in the Gulf of Alaska, 32-foot seas. This was as of Wednesday night into Thursday. Swell from that system has already hit the U.S. West Coast and the Hawaiian Islands and is all but gone. New system, the same system redeveloped on Friday, building 28, 30, 34-foot seas into Saturday morning, moving towards the U.S. West Coast, a little sideband energy towards Hawaii, and then this system as of Sunday 18Z now is off the U.S. West Coast. Swell is in the water, moving towards mainly California. You can see just a little shadow of energy hitting Hawaii. Most of it for the U.S. West Coast, but unfortunately, south winds, rain, generally inclement weather for the U.S. West Coast, other than maybe Southern California, and even that's a little bit iffy. So here we go. Current situation, significant wave heights again are 20, 22, 24, 25 foot, 25.6 foot seas right where the X is there. Aimed at the U.S. West Coast. We'll just roll this out, and you notice as we move into Monday, the system starts falling apart, and basically very raw, wind-driven swell hitting the U.S. West Coast Monday afternoon. Another system, we saw this again. This is the one moving off to the northeast Tuesday. Little patch of 30-foot seas, basically. This is good for the Pacific Northwest up into British Columbia, and probably some sideband energy into central California, but nothing dramatic. And then things sort of back off a little bit. But then remember, the gale started developing, or is forecast to develop off Japan trough, and sure enough, we see some seas forecast to build. Nothing dramatic, 25, 26-foot seas. What's that? 20, 22, 20. There we go. 25.2-foot seas, where the X is, of course. And 35 knot winds. That corresponds well with the GFS model surface level that we saw before. And that gets us out 180 hours. So that's good for probably 14, 15 second period swell for Hawaii and eventually the U.S. West Coast. But that would be the middle of not this coming week, but the week after that. Never believe a model born about 3 or 4 days out. So this is all fantasy land, but it suggests that the pattern should be improving if the jet improves, and we'll get a little bit more into that in a minute. And also, even though it's March, Southern Hemi is trying to come online. Small area here. This formed Saturday evening, was at 30, 32, 34, 36-foot seas or so. Now, very far to the south, notice there's hardly no ice coverage this time of year. Basically, it's the summer in the Southern Hemisphere. So storms that form way south actually generate seas, and some of that energy can radiate north. Now, this system, if you look at it, is moving basically east to west, way down south, not a whole lot aimed at Southern California. This is mainly a storm for Chile, and not even a big one at that, but just the same. And then another one behind it, small area on Tuesday, 30-foot seas, that fades out. And it was supposed to reorganize on Thursday, but it doesn't look so much like it. There we go. It tries to get going on right on the periphery of the Southern California swell window by Friday night with about 36-foot seas. Again, Chile, Peru, Mexico would probably be the better recipients of this system. And then we're out 180 hours and nothing after that. So actually it's kind of early in the season, but we are seeing some activity. So those breaks, Southern California might see some energy, but certainly South America, they should start getting their hopes up. It's looking like the season's waking up a little bit on the early side. So let's take a look long term. We're still tracking El Nino for 2015-2016, though it certainly is wrapping up. But still, there are some things that will have bearing on the surf and the weather forecast for the coming month or two. So let's dive into those details. First up, surface level winds courtesy of the TAO buoy array. Actual winds here, you can clearly see east winds. We're looking for west winds. Little bits of pieces of it south of the equator around the date line and west of the date line. With El Nino in play, you'd expect to see stronger winds, but the inactive phase of the MJO is in play over this region right now. That destructively interferes with El Nino, sort of tamps it down a little bit. And so, of course, we don't see a lot of west winds. And anomalies, wind, we're just looking at the arrows right now. Wind anomalies also next to non-existent. And we can just take a quick survey here, and specifically it is the Kelvin wave generation area, this area from about 130 right on the equator, 130 east to about the date line, 170, and 5 degrees north or south of the equator. We're looking for oranges and reds in here. Clearly we don't see it as of March 14th. We'll just blast through here to about here, and you almost get a sense of easterly anomalies as of the 18th. This is up at the 850 millibar level, which is about 4,500 feet in the air, but still that's a pretty good proxy for what's going on down at the surface. So not anything really in terms of westerly anomalies, and westerly anomalies in this area help feed the jet stream, help strengthen it, and then of course help produce storms, etc., etc. So for the next week, here we go. This is the Kelvin wave generation area. This is 5 degrees north and south. The core here at 3 north and south. And you can see easterly winds, trades basically, over the northern part, the southern part of the south of the equator. Really just sort of north winds, not a whole lot going on. Almost a little hint of west winds here near New Guinea, but that's nothing particularly noteworthy. And we'll just roll this out. We're looking to see what's going to happen over the next week. And interesting here, notice winds completely die out. Now, what that suggests is if trades die, that's the same as westerly anomalies. That would help feed the jet stream if, in fact, it comes to pass. And as we get into this, so for almost a month now, we just had very strong east winds up in this area all the way down here. And all that's supposed to fade out in the next well, this is Thursday here. We'll just roll that out, even get more pronounced into the weekend. Maybe those easterlies trying to come back, but not much. No west anomalies really of any magnitude that we're seeing, but normally you'd expect to see trades over this whole area, winds out of the east and probably in the 15 knot range, and we're really not seeing it. So that still means there's plenty of El Nino influence in this area. Another way to look at this, so here's the whole globe, west to east, if you will. The date line's right down the middle. These oranges and red are westerly anomalies. The Kelvin wave generation area, draw a line down here from about here to somewhere over here. Now, this is in February. We're looking past history. We had a good westerly wind burst. Westerly wind burst number 6 here in February into early March. But the other thing to note is you can have westerly winds. That could create a Kelvin wave, that is warm water pushing off to the east. But there's hardly any warm water left here because of 4 other Kelvin waves and actually more before that. So all the warm water that's typically over in the West Pacific has been transported to the East Pacific. And when that happens, El Nino collapses then. Here's the forecast for the coming week per the GFS model, and it suggests pretty much what we saw in the other chart. Little bits of what would be westerly anomalies, no actual west winds, but just no wind is the same as anomalies from the west, because normally you have trades in this area. So this is the forecast, about like what we saw earlier. Now, what we're also looking for is the MJO, Madden-Julian oscillation. The active phase right here is the blues. The inactive phase is the yellows. The inactive phase basically suppresses westerly anomalies or creates easterly anomalies. The active phase creates westerly anomalies, and that's what we want to see, but we want to see it over right in about here. So current state, this per the statistic model, suggests the active phase over the next 7 days is to work its way into the West Pacific and then start fading on the date line. And that's exactly what we saw in the jet stream models too, with the jet stream getting stronger, more consolidated in the West Pacific, and with the core of it making it to the date line. The dynamic model suggests a little bit different story, with the active phase making it into the West Pacific, then about a week out completely dying and disintegrating and becoming just dead neutral. Even if that were to happen, that would be good because that would allow El Nino to express itself, and it would still create westerly anomalies in this area and feed the jet stream and therefore feed the storm track, at least relative to where we are now. That should help heal the split jet stream at least to a point north of Hawaii. And yet, one more way to look at the MJO, this per these are called phase diagram charts. Imagine looking down on the North Pole from up above the Earth, down on the North Pole. You can go from the maritime continent, which is Indonesia, cross the dateline, Western Pacific, cross the dateline, U.S., into U.S. West Coast waters, across the U.S. into the Atlantic, and then back to the Indian Ocean. And the MJO travels this way counterclockwise around the globe. Current position of the active phase of the MJO is over the eastern maritime continent, poised to move into the West Pacific. Now, this forecast, this per the ECMF model, suggests it's supposed to do that over the next 4 to 5 days, but then is also the further away from the center, the stronger it is, the more towards the center, the weaker it is. It suggests the active phase is basically to collapse as it gets into the West Pacific. The GFS model basically says the same thing. So the thought is the MJO is going to die. But at least it won't be the inactive phase. We'll have some remnant piece of the active phase in the West Pacific. And we really like this chart here a lot. So what it suggests is, now this is a little bit different. Again, the date line runs right up the middle of the chart, but past history is here, and here was this westerly wind burst number 5, the orange and the yellows, westerly wind burst number 6 here in March. And now, right here is where we are currently. Notice no westerly winds. But then we see a big blob of westerly winds. Not as strong, not a westerly wind burst, but westerly anomalies forecast almost the whole way through the whole month of April. Let's overlay the MJO. And of course, these past two westerly wind bursts were associated with the active phase. The solid red lines are the active phase of the MJO. We're currently in the inactive phase, and that would explain the split jet stream and the sort of the slack in the swell machine. But notice the MJO is supposed to turn active, let's say in the far west Pacific, about March 25th or so, and continue in some form over the Kelvin wave generation area into almost the end of April. So if there was a sweet spot here for swell development, it would be pretty much the whole month of April. And then California is over here at 120. If there was a chance for rain, it would be somewhere, let's say the first week of April into, again, about the end of April. I would tend to think more the end of April. The early part of the active phase doesn't do a whole lot. It's more towards the tail end. Then after that, you go into the inactive phase. Westerly anomalies really slack off as you get into the first week of May. And that'll be it for our season in terms of the North Pacific. That's not to say there couldn't be activity during the inactive phase, but typically the more robust storm activity and swell production is during the active phase, so right in this area somewhere. So we've talked, here's the West Pacific, East Pacific here. We've talked about westerly winds over here in the Kelvin wave generation area, and that's right over here. But what the westerly winds do, they produce Kelvin waves, which is warm water that travels subsurface down about 100 meters and across the Pacific from the West Pacific to the East Pacific. They transport the warm water that's normally pooled up here in the West Pacific during El Nino years and push it to the east. During La Nina years, typically you do not have Kelvin waves, and so basically it's the opposite of El Nino. All the warm water builds up here, and you end up with cool water subsurface here in the East Pacific. Right now you can see big pocket of 29 degree Celsius water temperatures, making it to a point south of Hawaii. But this is the thing we haven't seen so far this year. The 28 degree isotherm pretty much stopped somewhere right around here. But notice now warm water is making it the whole way at the surface across the Pacific. So that's a good sign. That suggests a mature phase of El Nino. But now here's the anomalies, differences from normal. And what you see is we had a big pocket of 2 degree anomalies here that even 2 days ago. They've all but gone. We're down to 1 degree anomalies. The only 2 degree anomalies that are left are, basically off the Galapagos in a little pocket of 3 degrees. When we were in the peak of El Nino, 5, 6 degree anomalies were in this area. Also notice this much cooler water working its way across, sort of like a cold water Kelvin wave, but not really. The cool water that was here, because westerly anomalies kept the warm water flow, that kept all the cool water pulled up here. Now the west anomalies are backing off and the Kelvin wave machine is shut down. All of a sudden, cool water is starting to move towards its normal place because the wind isn't strong enough to keep it locked up over here, and we have 1 and 2 degree anomalies now starting to work their way at depth and undercutting the warm pool. This means that the El Nino surface warm pool will be in collapse shortly, and you can see it here on the high-res version as well. What's this? This is 1 and 2 to 3 degree anomalies, it says here, as of the 14th, but we're into the 20th now. I think on the next update of this image, you're going to see this all disappearing. And this is all that's left, this little pocket here. This suggests, was that 4 degree anomalies? And I think even that's a little bit optimistic. Still, there's probably a month or two of warm water still held up in this pocket. And you can, of course, see the cool water working its way off to the east. Sea height anomalies tell a similar picture. That is, strip out all the waves, all the tide, wind chop, everything. Just the differences. You get a little bulge like here. That suggests warm water at depth on the surface. Warm water, of course, expands a little bit, which creates the bulge in the surface. So we're talking 10 centimeters, 15 centimeters above normal. But this is south of the equator, right on the equator. Look at this. Pockets of dead neutral anomalies, and also that's showing up here along the coast. The Galapagos are there, and Ecuador. This suggests that temperatures are dissipating in the main El Nino area, which is, normally off of Ecuador over the Galapagos and out almost to the date line. A collapse is in play. And this is our favorite chart. You can track Kelvin waves, basically upper ocean heat anomalies, upper 300 meters of the ocean surface. You can see warm anomalies. 1 Kelvin wave here in April. Was this 1, 2? Kelvin wave number 3, very strong in the August-September time frame last year. Kelvin wave number 4 in the November-December time frame. And our last little Kelvin wave number 5. But notice here, look at this. Temperatures are in deep decline, rapidly moving out. Cooler temperatures at depth, working their way off to the east. The warm pool is just getting eroded, and we're quickly going to fall into some sort of a neutral pattern, if not a weak La Nina pattern. There's no warm water left in the West Pacific. So even if you did have massive western anomalies, you wouldn't get a Kelvin wave out of it because there's no warm water left to transport to the east. And if anything now, we'll get cool water working its way off to the east. Now, surface-wise, the typical El Nino signature is warm water. So we talked about west winds here, taking warm water that's normally here, and you notice it's cool water here, and pushing it to depth. It goes the whole way across the Pacific subsurface in the form of a Kelvin wave, erupts somewhere in this region, and creates a warm pool of water at the surface that then gets caught by the trades and blowing back to the east. So there is a pocket of warm water here. This is from Kelvin wave number 4. There's this thin little line of, 2 to 3 degree anomalies here. It was actually much broader even last week and 2 weeks ago. That is slowly thinning out. This was from Kelvin wave number 5, if you even want to call it that. Little bits of warm water here from Kelvin wave 5 number 2, but also notice there's sort of a cool tongue starting to show up here as well. That is also this sort of a sign of the beginning of the end for this El Nino. And here's a zoomed in high-res version. Now here's that tongue of warmer water from the Galapagos out to about 120 or 122 west, which is basically south of California. But this has steadily been getting thinner and weaker, and this is just the upwelling phase of Kelvin wave number 5. Kelvin wave number 4, all this area was just buried in these temperatures or warmer in the wintertime and in the December, January time frame, but that's all washed out now. We had a good line of warm water from Kelvin wave 5 building here along Peru. That's now in rapid decline in the past 3 to 4 days. We're actually seeing cooler water starting to show up along the coast. We had this tongue of cooler water that's starting to show out here too. So basically, the El Nino surface pool is in steep decline. And the icing on the cake, if you will, the 7-day trend of sea surface temperatures. And here are the blues. These are areas that are cooling. You can see it there. You can see it west of the Galapagos. Yeah, things are warming in little pockets here and there, but the reality is we would expect to see these blues starting to build over the next month over this entire region as the last of the El Nino warm pool starts fading out. There's just no more Kelvin waves to feed it, and so at some point it's just the warm water dissipates, and we see that's what's happening now. So we can look at these indexes too. Nino 1.2, this is the region between the Galapagos and Ecuador and a little bit west of the Galapagos. And you can see the temperatures have slowly been declining. I mean, they were never super high, 2-degree anomalies. It was higher than that at one point. But this whole El Nino has been westward displaced. Nino 1.2 never really got cooking compared to the 97 El Nino or the 82 El Nino. And it continues to be in decline, just a little bit over a half a degree above normal as of right now. Now, the Nino 3.4 region from about, 120 out to about 170 west, the main area for tracking El Nino, it is actually still doing respectably well. If it was a normal year and this was wintertime and we had plus 1.7 degree anomalies, that would be a moderate to strong El Nino. So we still have plenty of warmth there, and that helps feed the jet stream, of course, and helps promote thunderstorms in that area. And so, I mean, clearly there's still an El Nino signature present. We talk about things in decline. Yes, that's compared to its peak, but we're in March. When you have these sort of temperatures, you would expect this El Nino to still be productive well into May, and we expect that. And from a global atmospheric circulation standpoint, this is going to hang on into the fall of this year. But just looking at the fine details, we have a slow, steady decline in temperatures going on currently, again, at plus 1.7 degrees. So we've talked about westerly anomalies, we talked about Kelvin waves in the subsurface warm pool, we've talked about the surface warm pool in the Nino regions, and finally the effects of that warm water on the atmosphere. The Southern Oscillation Index is up next, talking about differences in pressure between Darwin and Tahiti. If we saw negative numbers here, that would suggest the active phase of the MJO. Clearly that's not in control. Now notice earlier in February when the active phase was in control, daily numbers, here we go, minus 50. El Nino enhanced Southern Oscillation Index active phase. Those are very deep numbers, 40 minus 49. And then boom, the inactive phase kicked in probably in the early March time frame. Things petered out. As you can see, we got a daily value of minus 4.3, but the 30-day running average sort of tells you where we're at. We're still well in El Nino territory at minus 13.92, and the 90-day average at minus 14.55. And here's a graphical representation of the 30-day SOI. Back in January 2014, that's when we first thought El Nino was coming on. The SOI dipped significantly, but then it sort of meandered around and still went negative, but we didn't really get like a real El Nino in 2014. But then in 2015, things really bottomed out. Here we go into the fall. Down in the minus 23 for the 30-day average there. Then things sort of bounced around again. So you can see the inactive phase, the active phase, inactive, active, inactive, etc. Inactive here. Here's an active pulse, another active pulse, inactive, and now we expect, based on the charts, that we'll have another pulse here in the April time frame, and then that'll probably be it. The MJOs can continue to cycle. If anything, it'll get stronger, but in terms of it integrating with El Nino won't make too much of a difference by the time you get into the mid to late May time frame. So relative to the Southern Oscillation Index, Tahiti is basically right here. If we want to see the Southern Oscillation Index start going negative, well, right now we see high pressure here, and what you really want is low pressure in the area of Tahiti. So that's part explains why the SOI is kind of neutral right now. But the point being, here we go, look about Wednesday or so, and you see this little area of low pressure starting to set up south of Tahiti. That should drive the SOI a bit negative, and all that high pressure that was here pretty much vaporizes a week out. And so the expectation is the Southern Oscillation Index will start dropping based on the GFS model. A similar sort of measure is the ESPI index, differences in rainfall between this area here north of Darwin and then this broader area over where normally the core of El Nino is, Nino 3.4 region. And you can look at the chart here. You see lack of rainfall north of Darwin, much more rainfall south of Hawaii in the Nino region. The current value is plus 1.3. That suggests a pretty good coupling with the atmosphere, and we don't see any reason why that wouldn't continue to go, especially if the active phase of the MJO moves into this region. That will enhance precipitation in this area and dry things out in this area. So again, El Nino still in play and reasonably well coupled with the atmosphere. And finally, the temperature forecast for the Nino 3.4 region. This per the CFS version 2 model. You can see where temperatures have been peaking out nearly 3 degrees in the Nino 3.4 region in the November timeframe and holding well through January. And then even in February, only dipping to 2.5 degrees above normal, which is way above normal. But here we are, we're in the, March, almost moving into April time frame. Temperatures definitely crashing and pushing towards, we said, 1.7, I think it was. There's the 1.5 line. Now, this suggests that temperatures are not supposed to go even to neutral, which is down here, but are supposed to be about 0.7 degrees by over the summer. This is a minority report. Most of the other models are predicting some sort of neutral to almost La Nina, sort of weak La Nina sort of thing. And NOAA's come out in their forecast suggests the same thing, temps down around here. So we're not believing this model completely, and it would be normal to go from El Nino into some form of La Nina after that, and it typically lasts for a couple of years. But let's be clear, also, just because you have a La Nina temperature set up in the October to January timeframe, the atmosphere, it's like a very big boat. It takes a long time to change. It's been heavily influenced by El Nino for 2 years now. It's not just going to shut off. So that would suggest that in the fall timeframe, we'd still have a pretty healthy jet stream, a pretty good, at least early season to the surf season in the fall, if one were to believe it. And certainly this coming summer, El Nino seems to enhance the storm track in the southern hemisphere, specifically around New Zealand in that area. We'll see how this plays out this year. So for now, gale working its way towards the U.S. West Coast. Storm, probably raw storm surf for most of California. And then a little bit of a pause, but the model suggests that the MJO is going to turn towards the active phase about a week and a half out. And by the time we get into April, almost the whole month of April is supposed to be dominated by some kind of active phase of the MJO, which should enhance the storm track, and we should ultimately end up with some rain and snow in the higher elevations of the Sierra, probably the latter half of April. And then after that, things will probably wrap up for this season. And then the southern hemisphere will start taking precedence. But for now, a reasonably decent future looks forecast. We suggest you go get any kind of surf you can when you can, because before you know it, it'll be over. We'll be in summer mode, and everyone will then be relegated to talking about the great El Nino of 2015, 2016. It was great in some places, maybe not so great in others, but there were moments of brilliance and definitely large surf. So kind of time to enjoy it now. Get the last of it while you can. So enjoy it. We'll do this again next week. Same time, same channel. See you then. Thanks for watching.